Hello and welcome to this AfterMaths episode, summer special, the Primary Maths podcast, the show where we talk all things primary maths with me, John Cripwell.
And with me, Becky Brown.
Hello, everybody. Hello, Becky. How are you this week?
Hello, John. Yes, I'm really well, thank you. Having a lovely summer. How about you?
Yeah, very well. Thank you. Very well. We seem to be wearing the same clothes yet again, Becky. Third week in a row. We really need to discuss wardrobe before next week's recording, I think. But this is the third of our summer specials. And we are taking a slightly more leisurely look, shall we say, at some mathematical ideas and thinking less about the classroom and less about pedagogy and more about just interesting things that we've noticed in the world around us.
Yes, we are. We've had a couple of episodes, John, haven't we, where we blew our minds a little bit last time talking about probability. We've talked about summer holidays and why they seem shorter than they once were. And what have we got in store today?
Well, last week's episode, I should say, made me grateful, not for the first time, that probability is currently not in the Key Stage 2 curriculum because it was when I started teaching, when you started teaching as well, Becky, I'm sure.
Yeah.
We did used to have to teach probability, but not for the last 10 years or so, and long may that continue because my mind was a puddle at the end of last week's episode, trying to figure out probability and all that stuff that's just counterintuitive. So if you're having, a really good day and you feel like you need to be brought back down to earth, maybe you've accomplished something and you're feeling, maybe a little bit smug, go and have a listen to last week's episode and it'll make you question everything in your life. Or equally, if you're having a really bad day and you want to hear two people just unable to compute what's happening when it comes to probability, because that will make you feel better about yourself, go back and have a listen to last week's episode because that's what you'll get out of it. You'll learn very little about probability, but you'll see two people having a bit of a breakdown live on a podcast.
Yeah, which is always good.
Always. Yeah, it's how I like to spend my summers, Becky, if I'm honest. So, halfway through or nearly halfway through, depending on where your summer is. Some of you might be halfway through. In Scotland, you might be going back already. If so, I hope that goes well for you. Today, we are going to be thinking a little bit about measures and measurement, because it's one of those things that we teach all the way from early years, all the way through really to Key Stage 4 in different ways. And I thought it had a bit of a summer maths feel to it because we do lots of travelling and things typically in the summer. Or if you're not lucky enough to be doing that, you might be at home doing some DIY. Either way, measures will probably come up, won't they, in one way or another.
Yeah.
And a question, I would lie and say that my daughter asked me this week. She didn't. But she has in the past asked, who decided how long a metre is? Where's that come from?
Good question.
Who got to decide that?
You have an answer.
And so, I thought that we might take a little bit of a deep dive into that and think about other units of measures as well and where they've come from. Because, again, we're trying not to talk too much about classroom practice and things, but I guarantee at some point in your teaching career, somebody will ask you, where's that? Why?
Yeah.
And if they don't ask that, then we're doing something wrong with our children, I have to say. They should be asking why. Why is 30 centimetres 30 centimetres?
Definitely.
Why is a metre a metre? So, can you think of any old units of measurement, Becky, even imperial, maybe, standard units of measures? How did we used to measure things?
I don't know if it's hands. I mean,
Hands.
In hand.
Yeah, it's how I measure the horses that we keep in the garden. Oh no, sorry, it's you, isn't it, with the stables and the different wings to your house and things and the country residence. Yes, actually, when you think about it, what's the other body part that typically gets used? Yeah, feet. So hands and feet were a unit of measurement originally, which kind of makes sense, doesn't it? In some ways, it's not a standard unit of measurement, though, is it?
No, I mean,
I think they've become a standard unit of measurement. If you're going to measure a horse in hands, I guess that has to be standardized now. Otherwise, what's the point?
It must be something, yeah.
Well, yeah, because, otherwise you've got jockeys who, being, slightly shorter in stature typically, would have different size hands to, say, a farmer who's got a shire horse, maybe.
Yeah.
But can you see that I'm out of my comfort zone here, Becky? But, yeah, it's not helpful to have unstandard units of measure, but I suppose it gave you an idea, at least, before these standard units of measures came in. There was also something called a cubit, C-U-B-I-T, which was roughly the length. See, this is where it's mad. A cubit was roughly the length from your elbow to your fingertip.
Okay.
Which fingertip? I don't know.
Okay.
Maybe there was a standard fingertip that you use for that. I don't know. A pace
Literally
is a unit of distance. Yeah. How, a pace. So you take 5 paces. That's how pirates used to measure things, isn't it?
I think we do tend to still, if you are marking something out, a sports, but in an informal way, not a formal way, you do still do that, don't you? I think we do that.
But I think people tend to do that to mean a metre now. I think you sort of pace out a metre. You try and estimate, don't you, with a pace, how far a metre is, maybe. Or is that just me? I don't know.
And dolly steps. I feel like we used to put our feet very...
Do you mean fairy steps?
Is that what... Oh,
dolly steps. Oh, maybe that's a north-south thing.
Yeah,
fairy steps, where you put your heel against the toe of your other foot. And yeah, okay. A span, so that is the distance between your outstretched thumb and little finger. Hand span, I suppose. But there were obviously clearly problems with this if you wanted to work with any degree of precision or accuracy, because famously, people come in different shapes and sizes, don't they? And one person's foot is definitely not the same. We know this. We have different shoe sizes. So, measurement was all over the place for a long, long time. It was very much a rough estimate, rough guesstimate, really. But I suppose it made sense, didn't it? At the time, you got a general idea, and that would have been the same. As opposed to if you'd use something like, I don't know, a table, for instance, it's a table's length. Well,
yeah, they're going to be similar enough.
Yes. Yeah. So then the imperial system, we probably missed some steps here, but the imperial system is the one that in the UK, we use most frequently alongside the metric system for various historical reasons, but we still use things like miles and pints, don't we? Yards less so, I think.
I don't think
I measure things in yards particularly, but we do measure things in feet. We talk about the altitude of a plane flying at so many thousand feet, or somebody being 6 feet tall.
Yeah, people tend to give their height in feet, don't they?
Yeah. And I think that's the same in America as well. Famously, they really dislike the metric system, it seems, in America. But lots of other countries have adopted the metric system and really don't use these imperial measures at all. So the foot, the imperial unit of measurement of a foot, was originally loosely based on the human foot. But actually, a foot is roughly 30 centimetres. So that seems quite a big foot.
That's
don't you think?
Yeah.
Yeah. An inch was historically associated with 3 barleycorns placed end to end, because that was ubiquitous. Everybody had barleycorns knocking about. Yeah. A Roman mile, you'll like this because we've not done any Latin or Roman stuff for a little while, Becky, comes from mille passus, which is 1,000 double paces. So that's the origin of the mile, 1,000 double paces. Whereas a modern mile is exactly 1,760 yards.
Which is a nice, easy number to remember.
Or, yeah, you're right, that's not the easiest to remember, is it? So let's do it in feet instead. 5,280 feet.
Yeah, that's crazy.
It is, yes. Why not use round numbers? You had the whoever decided this, and I don't know who it was, okay, but they had the opportunity to set it at whatever they wanted, right?
Yeah.
1,760. They could have even gone for 1,800, for
Yeah.
2,000 yards. 1,500 would have been better. Why 1,760? It makes no sense.
No, but then along came the metric system.
But this is why. So this is where historical context is important. The fact is that nobody sat down with a piece of paper and thought, okay, let's set out the mile, the yard, the foot, the inch. It was historical accumulation rather than design.
Yeah.
Yeah, nobody decided that 280 was the most beautiful possible number to represent a mile in feet.
No.
Where do you think first adopted the metric system en masse in force? Where in the world do you think, Becky?
England.
I was about to say we are still on air at that point. That little bit of dead air there. You don't adjust your volume or anything like that.
I'm just going to go for England. I don't think that's the answer. But
England?
Yeah.
I mean, we didn't adopt the metric system till the 70s, did we?
Well, I don't
We're
know.
going back here to the 18th century, Becky.
Oh.
The 18th century.
Italy.
You're closer. I'll put you out of your misery. So by the 18th century, France had a bewildering collection of regional measures. A little bit like time, as we were talking about a couple of weeks ago. Time varying between different towns and locations because there was no standard set time. Units varied in France between towns and between different trades and all sorts of things. And so they had a revolution. And as well as getting rid of the monarchy, they thought, well, we've got an opportunity here to make our lives easier in lots of ways. And we will replace one ruler with some standardized measures. Okay, a system based on the base 10 system with decimal relationships and the same units available to everybody everywhere in the country.
Well done, France.
Yeah. And the word meter arrives so we've had Latin, let's have some Greek. The word meter derives from the Greek metron, meaning measure. So a little bit of etymology for you there. Meter comes from metron, and metron meant measure. So in 1791, the meter was defined. And this is the problem when you try to define these things. You have to compare it to something else, don't you?
So it's going to be something complicated.
What did they compare it to, Becky? They needed something that wouldn't really change, that was fixed, even though we know it's not entirely fixed.
Oh, I can't think of anything.
No, that's tricky, isn't it?
Yeah.
You can't use most things in nature, trees and rivers, and things change, don't they?
Yeah. What did they go with?
Now, I think this is impressive. In 1791, they defined a meter as 1/10,000,000th of the distance from the equator to the North Pole along a meridian, an imaginary line that passed through Paris. I mean, that seems the most sensible approach, isn't it? 1/10,000,000th of the distance from the equator to the North Pole along an imaginary line that ran through Paris. So they calculated that the distance from the equator to the pole would be 10 million meters. That's what they called it. And therefore, a full circumnavigation of the Earth, a full meridian around the Earth, would be 40 million meters. And I know it sounds bonkers, but actually, they were trying to use a fixed distance.
I mean, that is fixed.
It is fixed. Why they couldn't have used, I don't know, the distance from Paris to, or a point in Paris to another point in another nearby town that would have been slightly easier to.
Yeah.
I don't know, but they didn't. They went big. They went big. Go big or go home, and they went big.
I wonder what that meeting was like.
I mean, it was an attempt to make it universal, still based upon nature, and essentially they replaced somebody's foot, maybe the king's foot, with the whole Earth,
Yeah.
or at least half the Earth. But this is 1791, so they didn't have satellites and things, clearly, in order to do this accurately. So a couple of astronomers, Jean-Baptiste Joseph Delambre and Pierre Metre, I don't know if I spelled that right, Michain, were tasked with measuring an arc of the Paris meridian. And they did a survey that went from Dunkirk to Barcelona, obviously. And then they used triangulation. So lots and lots of maths here, Becky. That's what I'm getting to. Loads of maths. They used triangulation to measure one baseline accurately, observed angles to distant landmarks, created a construction of a chain of triangles, and then calculated the distances that couldn't be measured directly. And this was all happening during the French Revolution. I'm sure that these two astronomers were quite happy to be out of all of that, measuring distances from Dunkirk to Barcelona. They dealt with war, political upheaval, arrest, damaged equipment because there were people suspicious of them carrying these pieces of measuring equipment and constructing towers and things. Difficult terrain, and it took them a little while to. It took them a little while to do it. It took them years. It was supposed to be a couple of months. It took them years to do this.
Wow.
And they realised that they were not still being particularly accurate, but they'd done a lot of work at this point.
Yeah.
So they sort of felt that they had to kind of present something. So they did, but they did realise that the resulting metre was not a perfect, exact 10 millionth of the quadrant. Because, who knew, the Earth is irregular and their surveys contain some errors. However, despite all that, the unit survived and is still the most commonly used unit of measurement of that kind of distance in the world. However, it was recognised that they needed something a little more concrete to have this measurement. So they created a physical meter bar to embody the unit. And it took them a century to do this. Not until 1889 they got around to this, really. But an international prototype meter was established in 1889, which is a platinum iridium bar. I'm guessing they chose that material because it's not likely to corrode and therefore is likely to stay the same.
Yeah.
It's stored near Paris, and the distance between two marks on the bar represented 1 meter under specified conditions of atmospheric pressure, temperature, and all those sorts of things. And then countries could come to this bar, compare their national standards with the international prototype, and then take it back. Again, there's slight problems with that because whatever you bring to Paris and then take back around the world has potential to change during that journey in one way or another, being stretched, being compressed, being squashed, whatever. So they had to refine it further, is what I'm saying. It took them until 1960. But in 1960, the meter was redefined using a particular wavelength of light emitted by an element krypton 86. And this finally moved the definition away from a physical bar, physical meter stick, and towards something laboratories could reproduce. And then in 1983, the meter was redefined using the speed of light. So we know that the speed of light in a vacuum is fixed at exactly, come on, Becky, off the top of your head.
Not a clue.
Oh, come on. Honestly, 299,792,458 meters per second, obviously.
Oh.
So we define the meter using the speed of light now. So that is a constant, a universal constant. That's kind of the evolution of the meter. So for everybody that's got a ratty meter stick in their classroom, you can tell the kids that we don't need to bother with those anymore. We're just going to measure a meter using the speed of light. Slightly less useful, I would say, for underlining the date on the board.
Yeah.
But,
Yeah.
nothing's perfect.
Well, I mean, that was pretty amazing. I mean, what a palaver to get there. But
I imagine that's what those two astronomers said at the end of it all. What a palaver.
The idea that is it still there in Paris, that meter stick?
I don't know. I'm guessing so. Can you imagine if they'd just thrown it away? Like, we've replaced it now. Get rid. Yeah, just get rid. Anyone need any platinum iridium bar? Yeah. I've got a couple of other things here, but I'm not going to go into it because I feel like we could spend another 40 minutes talking about pints and.
I mean, that was brilliant. Truly.
We've done temperature in the past, haven't we?
Yes.
Which is also bonkers. And therefore, what I've taken out of this is that people were really keen to have standardized units of measure, but it's much, much harder than it first appears to actually arrive at a standardized unit of measure that makes sense to everybody. And still, people don't adopt it all over the world. There's still resistance to it.
Yeah, it's bizarre. That was great. Thanks, Jon.
Anytime, Becky. Anytime. All of that just off the top of my head.
Yeah, amazing.
We will leave it there for this week. We hope you've enjoyed that. And that you can blow somebody's mind with that when you go back in September, perhaps, or just on a car journey wherever you're going this summer.
Lucky children,
or friends.
Yeah,
or friends. It's not just for kids. This amaze your friends.
Yeah, no, I love it. Thank you for joining us today, and please join us next time for some more summer fun.
Please join us next time. Please. Yeah, we will be back next week for another summer special, as Becky says. In the meantime, we hope you have a wonderful week.
See you next time. Bye, Jon.
Thanks, everybody. Thanks, Becky. See you next time.